Ordinary differential equations. Euler's method is a numerical procedure for solving ordinary differential equations, ODEs, with a given initial value. It is the most basic explicit method for numerical integration of ordinary differential equations and is the simplest Runge-Kutta method. Our formula is y, the initial y plus 1 is equals to initial y plus the function of the initial x and initial y times the step size. Ralston's method. Ralston's method is a second-order method with two stages and a minimum local bound error. Our formula is the initial y plus 1 is equals to initial y plus the 1/3 k1 plus 2/3 k2 times the step size, where k1 is equals to the function of the initial x and initial y, while k2 is the function of the initial x plus 3/4 times the step size, and the initial y plus 3/4 k1 times the step size. Yun's method may refer to the improved or modified Euler's method, that is the explicit trapezoidal rule, or a similar two-stage Runge-Kutta method, where our formula is the initial y plus 1 is equals to initial y plus the 1/2 k1 plus 1/2 k2 times the step size, where the k1 is equals to the function of the initial x and initial y. k2 is equals to the function of the initial x plus the step size, and the initial y plus k1 times the step size. Here is another Runge-Kutta method, which is the midpoint method, where our formula is the initial y plus 1 is equals to initial y plus k2 times the step size, where the k1 is equals to the function of the initial x, initial y. k2 is equals to the function of the initial x plus 1/2 of the step size times this 1/2 of the step size, and the initial y plus 1/2 k1 times the step size. Runge-Kutta fourth order method is another method for getting our initial values. Our initial y plus 1 is equals to initial y plus the 1/6 k1 plus 2 times the k2 plus 2 times k3 plus k4 times the step size, where the k1 is the function of the initial x, initial y. k2 is equals to the function of the initial x plus 1/2 of the step size, and our initial y plus 1/2 k1 times the step size. Our k3 is equals to the function of the initial x plus 1/2 times the step size, our initial y plus 1/2 k2 times the step size. Our k4 is equals to the function of the initial x plus our step size, and our initial y plus k3 times the step size.
Here we will have an example of a Euler's method. The function of xy is equals to 3e raised to negative x minus 0.4y. Our formula for Euler's method is yi plus 1 is equals to yi plus the function of the xi yi times the step size. If we will assume that the iteration is equals to 0, we can get the y1 is equals to the y naught plus the function of the x naught, y naught times the step size. Our x naught is equals to 0, our y naught is equals to 5, and our step size is equals to 3. Now we just plug in our givens. yi is equals to 5 plus the function of 0, 5 times the step size. Is equals to 5 plus the 3e raised to negative 0 minus 0.4 times 5 times 3 is equals to 5 plus 1 times 3 is equals to 8. This is our answer for Euler's method. Here we will have an example for Ralston's method. The function of xy is equals to 3e raised to negative x minus 0.4y. Our givens are step size is equals to 1.5, the x naught is equals to 0, and our y naught is equals to 5. Our main formula is the initial y plus 1 is equals to initial y plus 1/3 k1 plus 2/3 k2 times the step size. We know that we will now get our k1. 3e raised to negative 0 minus 0.4 times 5 is equals to 1. Our k2 is equals to 0 plus 3/4 times the step size 1.5. Then y is 5 plus 3/4 1 times 1.5 is equals to negative 1.476. Now we will just substitute the values from the k1s to our main formula. 5 plus 1/3 times 1 plus 2/3 times negative 1.476 times the step size 1.5. Now we will just simplify it. Is equals to 5 plus negative 0.6507 times 1.5 is equals to 4.024. That's our answer for Ralston's method. We have a example for Yun's method. We have the function of xy is equals to 3e raised to negative x minus 0.4y. Our step size is 1.5. Our x naught is equals to 3. Our y naught is equals to 5. We have here the main formula for Yun's method. The initial y plus 1 is equals to initial y plus the function of plus the 1/2 k1 plus the 1/2 k2 times the step size. Now we remember that to get the k1 and the k2, now we just substitute our givens to the formula for k1 and k2. 3e raised to negative 0 minus 0.4 times 5 is equals to 1. K2 is equals to 3e raised to negative 1.5 minus 0.4 times the 6.5 is equals to negative 1.306. Now we have our k1 and k2s. Now we just substitute the answers from k1 k2 to our main formula. 5 plus 1/2 1 plus 1/2 times negative 1.9306 times 1.5. Our answer is 4.302 for the Yun's method. We have here an example for midpoint method. The function of xy is equals to 3e raised to negative x minus 0.4y. Our step size is 1.5. Our x naught is equals to 0 and our y naught is equals to 5. Here is our main formula for the midpoint method. The initial y plus 1 is equals to initial y plus k2h. Our k1 is equals to 3. Our k1 and k2 has been given on the PowerPoint that I have just shown to you. Okay, we just plug in the givens. K1 is equals to 3e minus 0 to the negative 0 minus 0.4 times 5 is equals to 1. Our K2 is equals to 0 plus 1/2 times the 1.5, and our y is 5 plus 1/2 times 1 times 1.5 is equals to negative 0.8829. Now we have our answers from K1 and K2. Now we just plug in our answers to the main formula. Y1 is equals to 5 plus negative 0.8829 multiplied by the step size 1.5 is equals to 3.676. Our example for RK4, function of xy is equals to 3e raised to negative x minus 0.4y. Step size is 1.5, the x naught is 0, and the y naught is 5. Our main formula for the RK4 is the initial y plus 1/6 k1 plus 2k2 plus 2k3 plus k4 times the step size. Now we will just, given the k1, k2, k3, k4 formulas, we just plug in our givens. 3e raised to negative 0 minus 0.4 times 5 is equals to 1. Our k2 is 3e raised to negative 0.75 minus 0.4 times 5.75 is equals to 0.8829. Our K3 is equals to 3e raised to negative 0.75 minus 0.4 times 4.338 is equals to negative 0.3180. Our K4 is equals to 0 plus 1, 5 plus the step size 5 plus negative 0.3180 is times 155 is equals to negative 1.140. Now, given our answers for K1, K2, K3, K4, we just plug in that answers to our main formula. 5 plus 1, 6 multiplied by 1 plus 2 times negative 0.8829 plus 2 times negative 0.3180 plus negative 1.140 times the step size is equals to 4.365.